Hey guys, welcome to the video. This is Akash here, and a bit about myself. I'm currently working as a machine learning engineer in Reddit. And in today's video, I wanted to talk about a very common topic in machine learning called regularization. But I will not be talking about different types of regularizations that we have, but I'll mainly talk about the motivation and share an example regarding how regularizing will be very useful. This video also assumes that you have some basic knowledge in machine learning because that will help you to understand and grab the concepts and intuition. Okay, to get started, right off the bat, we have two plots here. As you can see, both these plots have exactly the same data set. Blues are the positives and O's are the negatives. But there is like one striking difference between the two graphs. Here, the machine learning model that we're trying to fit is linear, and here we are allowing the model to be non-linear. Now, since this graph, we can see we are trying to fit a linear model. So here, the model is trying its best to create a boundary to separate the positives and the negatives. But here, since the graph is non-linear, it's trying to capture every positive and every negative. So as you can see, all the data points on the left side of this black division boundary are all positives, and on the right they're all negatives. But here the model is trying to generalize it, and so you might see some misclassifications here, but you'll not see any misclassifications here. So if you have some basic knowledge in machine learning, you might know that this is a classic example of overfitting. Overfitted models have high variance, which means that if we were to sample another set of data points from the same distribution, and if we try to fit a model with that, you'll see a drastically or significantly different model behavior compared to what you see here. But for this one, if we take another set of data points, we might not see a significantly different model or decision boundary that we have currently here. So that's why overfitted models are generally not preferred. They will have amazingly less train error compared to generalized models, but in real world scenario or test data set, they will have significantly or moderately higher error compared to the generalized model. That's why overfitted models are generally not preferred in machine learning, and that's why we tend to towards generalized models. Now, the question might be that how does this relate to regularization? To answer that, we need to understand what is regularization. So regularization is basically penalizing the coefficient or weights corresponding to the input data points. So in this equation here, we have y1 hat, which is predicted y1 value to be f of some linear term. Here f can be any sigmoid function or any other function that basically transforms this linear term into like positive or negative. And here similarly we have y2 hat, which is predicted y2 value to be f of some kind of term which is non-linear. So if we compare this and this here, we have an extra term x square which captures the non-linearity in this graph. Now, since we have the predicted y values equation ready, we just need to have a loss function on these predicted values. If you are familiar with general machine learning, you might know that you need to have a loss function that basically minimizes the loss between the actual and predicted values. So for simplicity, let's say that the loss function is basically sum of least squares of the differences between yi values. So let's say the loss function is just this, here and here. Now, because we are regularizing, we will need to add some extra term that basically captures the penalizing that we are doing on the weights. Regularization can be multiple types, but for simplicity, let's just think of two types right now for this video. It's L1 and L2. So in L1, we basically penalize the sum of absolute values of the weights. So it's just W1 here, mod of W1. And here we have sum of mod of W1 and W2. And in L2, we basically penalize the sum of squares of the weights. So here is just W1 square, and here we have W1 square plus W2 square. So as you can see, we have a new loss function, which basically captures the penalizing of weights as well. Now, if we take a step back and if we see the loss function without the regularization terms, intuitively it means that the model will just try to fit or reduce the losses between the predicted and actual values, irrespective of how big or how low the weights get. Its main job is to just minimize the loss. Now, in the case when we do have regularization, we basically create a check on how large we want the weights to be. So here you see that we are trying to keep a check on the sum of W1, W2, and here we are trying to keep a check on the value of W1. And the lambda here basically tells us how much importance we need to give to the regularization term. Now, as we regularize, we make sure that we are making the model move from an overfitted state to more of a generalized state. And it can be seen in these set of equations that we have here. Now let's say we have a good value for lambda, let's say 0.1 or something that makes sure that we are effectively including regularization in the loss function here. Now, because we are regularizing, the values for the weights, which is W1 and W2, will reduce more and more as we increase the lambda value. Now, let's say there's a scenario where we have regularized a lot and W1 value has diminished and become smaller and smaller, and let's say it has reached to 0. Let's say W1 is almost 0. Now, in that case, what will happen is the y2 hat, since W1 is almost 0, we can neglect this term here, and y2 hat will basically be f of just W2x plus phi. And here phi is basically like an error term. Now, if we compare y2 hat now with y1 hat, we will see that both of them look exactly the same. So this is a perfect example of how including regularization help us to move the model from an overfitted state to more of a generalized state. Now here I just gave an example that if W1 becomes 0, it becomes exactly this. But depending on the lambda value and depending of which type of regularization you choose, which is L1 or L2, W1 value might be 0 or might not be 0. And that's about it. That's one example of how regularization can help the model reduce overfitting. And if you do have any questions or concerns, please do let me know in the comments below, and I will catch you guys in the next one.